Hello, hello. We are back with Chapter 10, Probability, focusing on Lesson 3, Sample Spaces. Now, the set of all possible outcomes to an experiment is called the sample space. And whenever you see the word set, that just means like group. So a group of all the possible outcomes to an experiment is called the sample space. And that's what we're going to be focusing on today. So let's talk about the sample space if a coin is rolled and then you have a number cube. What are all the possible outcomes? How many outcomes are in the sample space? And really, to represent this data, you can do it in two ways to show the sample space for an experiment. You can make a list, or you can make what's known as a tree diagram. Okay? So let's go over how to make a list first. Okay? So to make a list, the possible outcomes, you want to look at the possible outcomes. So let's say we have a coin. What are the two things that you can do with a coin? Well, if you have a coin, right, you can either flip a heads or a tails, right? Those are the possible outcomes. So the possible outcomes for tossing a coin are heads, which for this purpose, we'll just use this like parenthesis H. That's going to represent heads. And tails, we're going to use the T for tails. Okay? So those are the outcomes for flipping a coin. You can either flip it heads or tails, right? What about a die? Well, you could roll a 1, you could roll a 2, you could roll a 3, a 4, a 5, or a 6. So there's 6 different outcomes. You could roll a 1, 2, 3, 4, 5, and 6. So the sample space in the form of a list would look something like this. If, let's say, let's just talk about heads or tails. So you can flip either. So let's imagine we flip a heads, right? And we do these at both times. So we roll and we're going to flip a coin at the same time, and we end up flipping a head, and let's say we could flip a 1, or we could roll a 1. So that would be the first option, right? Would be flipping a head and rolling a 1. So that is noted as H1, okay? So what we want to do is we want to write down all of the options if we randomly were to flip a heads first, okay? So we could, if we flip a heads first, okay, we could roll a 1, right? That's heads 1. Or if we flip and roll at the same time, another possibility that could be an option would be flipping a head and rolling a 2, so that's head 2. Or another option would be flipping a head and rolling a 3, which is H3. Or another option would be flipping a head and rolling a 4. Or another option would be flipping a head and rolling a 5, which is H5. And the last option would be flipping a head and rolling a 6. So right here. Now these are all of the options for flipping a heads first. Right there. There's nothing else, there's no other option or outcome that can happen. Okay, we have all of the possibilities for a head being flipped right there. Those are all of the outcomes in the sample space. So now we have to imagine, well, what if we didn't flip a heads first? What if we flipped a tails first? Well, what are all the outcomes if we flip a tails first? Well, if you flip a tails first, you could roll a 1, right? Tails and 1, or you could roll a 2, where's the 2, right? Tails and 2, or you could roll a 3, that would be T3, or you could roll a 4, so you flip a tails and roll a 4 at the same time, or a 5, or flipping a tails and rolling a 6. Those are all of the options. So for flipping a tails first. So what we want to know, that's the entire sample space. There's no other options. That's everything. So what we want to know is how many outcomes are in this sample space. Well, we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible outcomes in the sample space. So that is writing the list, okay? So the next thing we're gonna look at is how to make a tree diagram, okay? So a tree diagram, what you do is you take one thing at a time. So you know when we're doing this, we're flipping and we're rolling, right? That's what's happening. We're trying to come up with all the different possible scenarios that can happen, but we're going to do it in a systematic way. So let's just stick with heads, okay? Let's say, hey, if we roll a heads first, what are all the options? Well, just like the list, you can, if you roll a heads first, you could roll a 1, which we're going to call H1, or if you flip a heads, you could roll a 2, which we're going to call H2, or, where's our 2? 2. Or you could roll a 3, which would be H3, or you could roll a 4, which would be H4, or a 5, which would be H5, or roll a 6, which would be, where's that 6? There you are, which would be H6. So it's just kind of a different way of writing the same information. So this right here, these are all the options for rolling a heads first, or flipping a heads first with the rolls. So this is the same information. This is in list format. This is in tree format. Well, the whole thing's really in tree format, like this whole thing, everything. The whole thing is the tree diagram. Okay, so that represents this information right here. Or we could do, let's imagine all the possibilities for the tree diagram if we were to flip a tails first. Well, it's going to be the same thing, right? You could go tails and roll a 1, which would end up being T1. Or you could roll a 2, which would be T2, tails, and then rolling a 2. Or you could roll a 3, which would be tails, and then 3, which would be T3. Or you could roll a 4, which would be tails 4. Or you could roll a 5, which would be T5. And lastly, you could roll a 6 with the tails, which would be T6. And so this is all the same information that we had before up here that's pink, but now it's in a tree diagram right here. So this is how you would do a tree diagram for the same scenario. Just like this. Okay, and you can do these where this is kind of a horizontal, or it can be vertical as well. Usually when I do trees, I do them vertically, but yeah, you can totally do them horizontal. And you can see the number of outcomes are right here. So we count these and these. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how that works. All right, let's go ahead and flip the page and talk about the next thing. Ooh, this is fun. You can also find the number of possible outcomes by using the fundamental counting principle. The fundamental counting principle, that sounds official. I'm just going to say it, it does. The fundamental counting principle. Let's see what that is. The fundamental counting principle is the total number of outcomes for 2 or more experiments, which is what we have, right? Because we're doing an experiment that involves flipping a coin and rolling a die. So there's 2 things happening at the same time, okay? So that would be 2 or more experiments. Can be found by multiplying the number of outcomes for each separate event together. Let's go ahead and look at what that is talking about, okay? So let's go back to our example with the coin and the die. So it says this is the fundamental counting rule. We're going to multiply the possible outcomes for each event. Okay, so when we're flipping a coin, this is how this works. How many options do we have for flipping a coin? Well, we can flip either a heads or a tails, right? So that means there are two options. You can flip a heads or a tails. So there's two outcomes. How about rolling? How many outcomes are there for rolling a number cube? Well, you could roll a 1, a 2, a 3, a 4, a 5, and a 6. That means there's 6 different possibilities for rolling a number cube. So what the fundamental counting rule says, that the shortcut, the cheat rule, is by if you take the number of outcomes for each thing and you just multiply them by each other. So we go, there's 2 outcomes for flipping a coin, and there's 6 outcomes for rolling the number cube. 2 times 6 is 12. 12 possible outcomes. Boom. That's it. So compare that with making the tree diagram and counting them all up, or the list and counting them all up. The fundamental counting principle actually makes, you can do this really good. Okay, really quickly. How many ways are there to flip a coin? Well, there's 2. How many ways are there to roll a cube? There's 6. Boom. 2 times 6 is 12. There must be 12 possible outcomes. Done. I don't know. I think it's kind of cool. Well, let's go ahead and try some problems in the next video. And yeah, so I'll see you in a bit. All right, goodbye.